foundational dirt for some reason. I don't know. Whatever. We don't know. Okay, so what questions do you have from the midterm? That was not a question from the midterm. Good try though. You can try a little harder next time. Nobody had any questions from either day. That's crazy. Gina was starting to ask the question, and then I decided to lose patience. So, you know. Did you have a question? No? Yeah. I wasn't talking to you that time. I was talking to Gina still.
Can we do number 15?
15. From which day?
Oh, from the
second day. On the second day of second grade, something, something, something. I don't know, can you? You may. Use Kramer's rule to solve the following systems. I wrote matrices apparently, but you know. You knew what I meant, possibly. Yeah. Oh, that's 12 that I'm looking at. What are you talking about? You're talking about 15. Oh yeah, solve by the method of your choice. That's not Kramer's rule. All right, what should we do? Attempt to factor it, and then when that doesn't work, cry into our soup and choose a different method. Which method do y'all want? You got two options. This is 15. What? Okay, completing the square it is. Let's do it. What should we do?
Put two parentheses? No, that's the wrong one.
I literally already said we try to factor it, and when that fails, we cry into our soup. And since you don't have any soup, you better go get some soup and then cry into it. That's my response to the very valid question that people ask when they're like, pull yourself up by your bootstraps, and then the person asks the question, what if they don't have any boots? It's a very valid question. It's a great question. It's a good question to ask. Good question to tease out a much more nuanced conversation. My response is, give them boots, and then tell them to pull themselves up by their bootstraps. You can have both things. It's amazing. I was not demon horns on purpose. I promise I'm not a Satanist. Okay. Before we do the green part, we got to do something else. We should add 2. Now what? The green part. What's the green part? B divided by 2 squared. So negative 3 divided by 2 squared. Negative 3 divided by 2 is negative 3 divided by 2. Imagine that. Negative 3 divided by 2 squared is 9/4. Now what? Add it to both sides. True enough. Plus 9/4. We can't just add 9/4 over here. We got to do it over here. Easy peasy. By the way, you could also just use the quadratic formula. That would be another way to solve this problem. Whatever. Anyway, continuing on. What now?
X minus 3/2 equals...
Oh, you forgot something important.
Oh, quantity squared.
17/4 is what my brain tells me. Is that what your brain tells you? Or your calculator or whatever tool you happen to be using?
Yes.
Now what? Yes, when we take the square root both sides, what do we end up with? No, not what I'm asking. What do we end up with when we take square root of both sides?
Now it's square root of fraction.
You can square root a fraction.
Square root the top and bottom. So
When we take the square root of both sides, what do we end up with? Not what I'm asking.
x minus
Not what I'm asking. You got to remember something. When you take square root of both sides, what happens?
plus or minus.
Plus or minus. Okay, now that's easy peasy. Okay, so we've got x minus 3 halves equals, what's the square root of 17? Square root of 17. Great. Is it reducible? No. Okay, good job. What's the square root of 4? 2. Now what? No, x is not by itself.
You have to add
You add
3
the
halves.
both sides.
3 halves plus 3 halves. They're already like terms, so we can just shove it all together. Equals 3. Oh, I went on this whole yelling spree of plus or minus. We went through this whole thing, then I forgot to write it down. So we have 3 plus or minus the square root of 17 over 2. Wham. You would get the exact same answer if you use the quadratic formula. See, the key even did it that way. What other questions from the midterms?
Can we do 12 from day 2?
Yeah. That's the one I was trying to do. Until Gina was like, what are you talking about? I didn't say that number. You lost all the marbles you had, which wasn't very many, but, you know, who's counting? Gina, apparently. You see, this is what happens when you show up on Thursday. It becomes Pick on Gina Day.
Yay!
It's going to be real fun in pre-calc because we get to pick on Gina while doing trigonometry. It'll be great.
So you're going to be picking on me while I cry over trigonometry. Is that what you're saying?
I don't know. You might not cry. You might love it. Trigonometry is kind of awesome. Especially the unit we're in right now in pre-calc. It's so much fun. All kinds of puzzles. Puzzles on puzzles. And a whole page worth of identities to rememberize. So great. The destructions say, solve using Kramer's rule. So what do we have to do?
You have to find the one that you divide everything by. Like, is it called like determinant?
We do have to find some multiple determinants. Yes.
Just the first one by just doing 5 over 5, 2, 3.
Mm-hmm. Just the coefficient matrix. What other matrices do we have to find the determinant of?
X and Y.
The x1 and the y1. How do we find the x1?
You take the Y ones out and substitute 7 and 1.
Yeah, for the y1, right? The x1 replaces the x's, and the y1 replaces the y1 replaces the y's, right? Yes. How do we find the determinant of a 2 by 2 matrix?
You multiply the crosses, like 5 times -1,
Mm-hmm.
and then you add them, right?
Nope.
Or you subtract them.
Subtract. Do the down diagonals minus the up diagonals. 5 times -1 is -5, and then minus 3 times 2 is 6. What is -5 minus 6?
-11.
Excuse me. And then the down diagonals here. 7 times -1 is -7. 1 times 2 is 2. So -7 minus 2, which is -9. And then 5 times 1 is 5, minus 3 times 7 is 21. 5 minus 21 is -6. Now we've got all the determinants. What do we do now?
16.
Yeah, teen. That's true.
Now you put them over 11.
Now you put them over 11. That's right. So the answer is positive 9/11ths, 16/11ths. Which would be a much more annoying answer to find using substitution. But pretty easy with Cramer's rule. What other questions do we have? I've said this kind of thing before, but I will say it again because it matters, and for the one or two of you that it matters to, it matters a lot. Why are you raising your hand in the middle of my sentence? Stop, calm down, put a pin in it, jot a note down if you need to remember it. If you missed 3 or 4 from day 2, you really, 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 really need to spend some time in Khan Academy or somewhere, or schedule some flipping office hours or what the heck ever. You don't need to, at this point in January in Algebra 2, need to have a gap where you can't graph a line. It's okay. It's called a gap for a reason. We close the gaps. Grades and marks off of things are information, not condemnation. If we use information, our lives get better. If we ignore information, our lives get worse. So use the information, fill the gap, and do it. If you just shaded wrong, you know, whatever, I guess. But like, if you didn't graph the line right, there's something going on. If it's like some sort of careless mistake because you like didn't notice a negative or something, like, I'm not talking to you, like, what, that's fine. But like, if you can't graph a line today, January 8th, 2026, Algebra 2, that is a gap that you need to fill. Does this make sense? Now what's your question?
Can we do number 6?
Sure. Same day? Same day, he asked?
Yes, thank you.
Okay. Good. Good, 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 good. Okay, what do we do?
You row by column.
You row by column, because we're multiplying. -2 times 8. -16. Are you adding the numbers or subtracting the numbers or what?
You
Add them. So plus 4 times -4 is -16. Okay. -2 times 12. -24. Plus 4 times -5.
-20.
Last column. -2 times 3. I got that one. That's hard. I got it. -6. I know. I saved your bacon. You would have had to think real hard on that one. 4 times negative 5, we already did that number. That's 20, but it's negative. I almost made a mistake, for all you know, on purpose. Jump down here. Negative 5 times negative 8. Except it's positive 8, but you know. Negative 40. That took a depressingly long amount of time for somebody to answer. What's happening, kids? Was I right? And it is more difficult than I thought. What is 5 times negative 4?
Negative 12.
Wow. Negative 5 times 12.
Negative 60.
And 3 times negative 5.
Negative 15.
Negative 5 times 3.
Negative 15.
Negative 15. And then 3 times negative 5 is also negative 15. And then negative 16 minus 16.
Negative 32.
Negative 32. Negative 24 plus negative 20.
Negative 44.
Negative 44. Negative 6 plus negative 20.
Negative 26.
Negative 40 times negative 12.
Negative 52.
Negative 60 plus negative 15.
Negative 75.
And finally, negative 30. Look, Mom, we did it. Yay. We could probably do 1, maybe 2 more midterm questions if we needed before we jump to today's stuff.
Can you do 4 from day 2?
4 from day 2, no. But you can schedule some office hours.
So, since the first one is negative of 4, would it be flipped? Is there like some rule about that?
Only if you're multiplying or dividing both sides by a negative.
Okay.
That's a good question. What else from midterms? Same day? Did I already take questions for the midterm? We're going to do 17, but did I already take those on Tuesday?
Yeah, you took them on Tuesday.
Because I realized that we did 18. But that's fine. We'll do 17, and then we're going to peace out and get back to our other stuff. What do we do? Distribute the negative, which is going to flip both of the signs. Definitely had like representative of every possible like small mistake you could make on this problem. Right? The 3 is going to turn negative and the 7i is going to turn positive, right? Also, this doesn't now somehow magically turn into multiplication, right? That minus is still in the middle, right? So all we got to do now is combine like terms, right? There were several different types of errors on this particular problem. But it's simpler than many of you were trying to make it. All right, let's do today's stuff, shall we? polynomials. Everybody's favorite Power Ranger. When I was a child, I was one of the many people my age who were not allowed to watch Power Rangers.
Really?
And then as an adult, when I look at Power Rangers, I'm like, yeah, I didn't miss much.
That was peak cinema, actually.
It was definitely not. You talk about that. You say cinema. So you're talking about the new movie thing, because
No.
that's even worse than a
Sorry,
TV
okay,
show, and
that
that's
was
saying
peak
something.
television. They turned into big dinosaurs. That's the coolest thing.
Yeah, by stealing footage from Japan. Good job, team.
I loved dinosaurs and I loved punching, okay?
They didn't turn into dinosaurs.
There was a series where they were dinosaurs.
Yeah.
I think it was two, I think.
The only one that I watched anything of was the very original. All right.
Yes, yeah. They turned into dinosaurs.
I think it was like Dino Force or something like
They turned into Zords. That's not dinosaurs.
There's one where they turn into dinosaurs. I am telling you. Hang on.
We're on 5-5. Does that sound right? What numbers did we do? I didn't understand anything because we were at different points in answering the question. What numbers did we actually do? 20 through 56. 50. Number 20 is quantity 2c minus 3d times quantity 4c squared plus 6cd plus 9d squared. 22. A squared times quantity a minus b times quantity a squared plus ab plus b squared times quantity ab times quantity a squared minus ab plus b squared. 24 is prime. 26, quantity x plus y times quantity x minus y times quantity 6f plus g minus 3h. 28, quantity a minus b times quantity a squared plus ab plus b squared times quantity x minus 8 quantity squared. 30, 3, negative 3, plus or minus I times the square root of 10. 32, excuse me, plus or minus the square root of 11, plus or minus 2i. 34, negative 6, 3, plus or minus 3i times the square root of 3. 36, x squared squared plus 12 times x squared minus 8. 38, 2 times 2, x cubed squared. 3 times 2x cubed plus 7. 40, 3x to the fourth squared minus 7. 3 times 3x to the fourth plus 12. 42, plus or minus I times the square root of 5, plus or minus I. 44, plus or minus the square root of 2, plus or minus the square root of 6 over 2. 46, plus or minus the square root of 2, plus or minus I times the square, plus or minus I times the square root of 3 over 2. 48, 5 years. 50, quantity x plus 2 times quantity x squared minus 2x plus 4 times quantity x minus 2 times quantity x squared plus 2x plus 4. 52, x squared times y squared times quantity 2x minus 3y times quantity 4x squared plus 6xy plus 9y squared. Excuse me. 54, quantity 6x squared minus 5y cubed plus 2z squared times quantity a squared minus 4b squared plus 3c squared. And 56 is x squared times quantity x plus 5 times quantity x minus 5 times quantity 4x minus 3 times quantity 5x plus 2. Questions do we have?
Can you do
22. Sure. questions do we have? I mean, what questions do we have? What do we do?
You take out an a squared.
Sure, let's take out an a squared. When we take out an a squared, what's left?
A to the fourth minus b squared.
You lied.
8. So a to the sixth.
It is a to the sixth. Oh wait, that's not all we can do. I lied. You lied first. It's not my fault.
You can do the difference of two squares.
We can do difference of two squares. What's the square root of a to the sixth?
Oh, a to the fourth.
Nope. 6 divided by 2 is not 4.
Oh,
3.
3.
Plus, minus. Anything else we can do?
Why would you not put it in that formula where it's like a plus b equals a squared plus or minus like ab minus b squared or whatever?
What are you talking about?
The difference of two cubes formula?
Oh yeah.
Oh, look. There are more things that you can do. Because we've got a sum of cubes and a difference of cubes. What's the sum of cubes formula?
A plus b times a squared minus a times b plus b squared.
I'm mixing up all my letters to try to make them not match that, but whatever. You get the point. Look at your notes for the formula. Okay, so what is this one going to turn into?
A squared times a plus b.
A plus b times
Times a squared minus a plus b, a times b.
plus b squared. And what's the difference of two cubes formula?
A minus b times a squared plus ab plus b squared.
Now we did it.
We do 26.
Sure. Excuse me. Okay. What should we do?
We try to get the positives and negatives the same
Potentially.
by doing like the grouping thing.
Mm-hmm. So what should we do?
Could we convert one of them to like a negative or a positive somehow?
Potentially.
Because there's 3 positives and 3 negatives, so it can be even on both sides. Or could
I'm not even worried about the signs yet. Not really. There's another sort of arrangement issue. Definitely going for grouping. This is clearly true.
You need to go in descending order from highest to smallest.
Look at the. You're talking about. What are you talking about? The coefficients in the front or the exponents?
The ones in the front.
Oh yeah, no, that doesn't matter.
We need to group the x's and y's together.
Definitely should group the x's and the y's together. Definitely should do some associative property and get the ones with the x's on one side and the ones with the y's on the other side, right? That way we can do some factoring. The one with the h and the y is this one, plus 3h y squared, and the one with the f and the y is this one, so minus 6f y squared. So I did two things. I got all the x ones over here, and I got the y's over here, and then I also did it in the same order. So like this one's got a g, this one's got an h, this one's got an f, right? So then we've got it matching as close as we can. Now that it's kind of aligned properly, now we can look at the signs and see whether they match or whether they're opposite. So do they match or are they opposite? They're opposite. So let's start with the first one, and then we can factor out a negative in the second one. Then they'll match, right? So what are we going to factor out in the first one? X squared, right? And then we write down what's left. So it's g minus 3h plus 6f. Then we pull out a negative y squared on the second one. And then it matches. G minus 3h plus 6f. Right? What? We're factoring out, yeah, the thing that matches, right? G minus 3h plus 6f times x squared minus y squared. Now, we need to, before we circle it, we need to see if there's anything else we can do.
Difference of 2 squares.
Difference of 2 squares. So that factors into x plus y and x minus y. Now before we circle it, we want to double check, make sure if there's anything else we can do.
We could break out g minus 3h plus 6f, right?
How?
No, never mind. If the h and f are the same.
Even then, we wouldn't be able to break it up. They'd have to all be the same, and then we could smoosh it together. So there's not anything. You're grinding gears for nothing. Good job. Okay. What other questions? 42. Sure. Excuse me. Okay, what should we do? We certainly should factor it. How do we do that?
By 2 parentheses.
Yeah, we can. You could also use substitution. That would be fine. You're still going to end up with 2 sets of parentheses. This one's probably easy enough without the use substitution. Not worry about it. What's going to be in the first slot?
5.
The first slot.
Oh,
Oh,
x
x
squared.
X squared. And then what about that second slot? 5 and 1. What are the signs going to be? Plus and plus. Does the end sign match? Yes. Plus times plus is plus. Now what?
Multiply 5 by x squared.
Why would we do that?
You just circle it over again.
We don't have x equals. It is factored and equal to 0. What can we do now?
Solve that equation. Like do x squared plus 5 equals 0.
Yeah, we can split it up, right? Set each factor equal to 0. X squared plus 5 equals 0. And x squared plus 1 equals 0. 2 days ago, I asked the same question of my pre-cal students. Now, there was a lot more junk in the parentheses. It was ugly. It's completely factored equals 0. What can we do? Even if there's a bunch of crap in there, you can still say each one equal to 0. Now what?
Subtract.
Yeah, subtract 5, subtract 1. So x squared equals negative 5. X squared equals negative 1. Now what?
Do the square root of both sides.
We do. What do we end up when we take square root of both sides? Plus and minus. So x equals plus or minus. What is the square root of negative 5?
Negative 5.
Definitely not. Negative 5 times negative 5 is definitely not negative 5.
But you can't find the square root.
What is the square root of 5? Let's start with that question. Square root of 5, right? It's not, it can't be reduced. What happens when we take a square root of a negative? It doesn't become a positive. We put an I. That's true. Plus or minus I times the square root of 5. And plus or minus just I. Because square root of negative 1 is I, right? Easy money. Sure. Thirty is like the same thing.
Yeah, but you can't factor it.
We very clearly can according to the key, but let's look at it. Unless the key is absurdly wrong, but I suspect it's not, because 90 is not that bad. In fact, it's kind of obviously factorable. Well, let's go for it.
But what two things multiply to get 90? No, like, because you have to get 1, right?
Yeah, what's 9 minus, what's 10 minus 9? Okay, I think we got that one.
Can we do 38?
38.
Yeah, I agree with that.
Well, I'm glad we have your blessing. Write it in quadratic form if possible. Spoiler alert, it's possible. Okay, time out. This is not the first, probably won't be the last time I make this little note. If you take your little eyeballs and you look at 38 and then you scooch them to the left of the page, what do you see? Example 5. So if you want a good walkthrough of how to do 38, where could you look? Example 5. I'm going to walk it through with you, so you don't need that now. But like when you're sitting at homework, you'd be like, I don't know if you talked about that. Spoiler alert, I didn't. You can go and be like, oh, that's how you do it. Or you might be like, oh, that's how you do it, but I don't understand what I'm looking at all, and I'm still going to ask. That's also fine, right? That's still good. Okay, quadratic form. It means that it's got an x squared, an x, and an ox. That's what we're talking about, right? So we need to use some words. We need to use some exponent rules to see if we can switch this up to where there's a squared up here and there's a first up here. Okay? So, when we have a power to a power, what do we do with the exponents? Multiply them. All right, so we need to divide these. We need to pull out a Another thing is if you have like bases multiplied, what do you do with the exponents? You add them, right? So we need to either pull this out this way, or both. So far, so bueno, right? What goes into 8 and what goes into 6? 2. True enough.
You also like, do you have to pull out the 2 to simplify it, or could you just skip that part?
You're going to need them to match, and they don't match yet. Because what's inside the parentheses in the quadratic form, what we're trying to do is we're trying to get it to be something like this. And this has to match. They don't match yet. So we need to match in the inside. They need to be literally the same. We can turn both of these into 2 with multiplication, right? So we can have a 4 out here, and then there's going to be a 2 in here, right? Because 4 times 2 is 8, right? Easy peasy so far. No problemo. No big deal. We got this. Now what could we do?
Then would you put x and then x squared and then quantity times the 3, the cubed, so that you could have it as squared?
So x cubed and then squared. Now there's a problem with this first term because this is not going to equal this anymore. Why not? Because 2 squared is 4. So what do we need to change this number to? A 2. Now how can we turn this into something times and raised to something that's where it's got 2x cubed in parentheses? Yeah, we did it. What other questions? Quiz? Okay, great. I love it. Ready to go. I will give you a hint because it's a quiz and we're not doing too bad on time, but it's a quiz and not a test and not homework. One and only one of those three is prime. One of them is not factorable.